Welcome to Bowditch Chapter 3, Navigational Calculations, starting with magnetic compass error. Now this topic is important for dealing with the magnetic compass on your ship. Most of the calculations are done with true and use of a gyro compass. But on small boats for emergency sailing and for Coast Guard testing purposes, you need to know magnetic, and it's the basis for the rest. So let's get started. The main formula you need to know is C D M V T. All right, CDMVT. This is starts out. C is the compass reading. This is the raw compass reading, right, from the magnetic compass. D is for deviation. Deviations are how the ship reacts with your magnetic compass at different headings. M is magnetic corrected for deviation. V is variation. Variations are changes that due to the offset of magnetic north and local topography, geology. Variation is found on your chart. It should be inside the compass rose on your chart, and some of the advanced GPSs have it precise variation for your actual location, whereas deviation you're going to have to look up on a compass card, magnetic compass table, which we will get to shortly. And finally, T is true. Most of our celestial calculations and so forth will be done in true and then converted over. So one of the main questions here is, how do you tell the difference between deviation and variation, or more importantly, how do you remember the difference? Well, I like to think of deviation as deviant, all right? Deviation is the change, how your ship affects your magnetic compass. Now, mostly it's the relationship of your ship to magnetic north. So the heading you are on changes the deviation. But deviation can also change. Some ships, like container ships, have two different compass cards. One for loaded, when they have all these steel boxes in front of them that are affecting the magnetic compass, and one for unloaded, when all those boxes are away. You can also change deviation by, say, a heavy lift ship with a large crane. If you were to swing that crane over, that crane has a lot of steel. If you were to swing it over to the port side, your magnetic compass is going to react, and there's going to be an additional deviation to the equation. So deviation, I like to think of as deviant. Imagine a deviant who's like a gremlin, someone who's trying to do harm to you, jumps in the crane, swings that boom out while you're trying to do these calculations. All right, that would change your the deviant actions would change your deviation, and that's how I remember the difference between deviation and variation. All right, what we want to first look at is the formula and how we apply the corrections. So a lot of people remember this formula by, can dead men vote twice at elections? All right, this AE is important. We're not going to assign a number to it. It just tells us that in this direction, when we're going in this direction, we want to add easterly corrections. All right, and conversely, when we go in this direction, we want to subtract westerly. Right. Some people think of it in the opposite way, and for them, it's true virgins make dull companions at weddings. Which way you prefer is really personal preference, as long as you think of one. But in this way, when you go in this way, you add westerly corrections, and you subtract easterly corrections. Now let's ask why. To ask why, look at a compass. All right, and this is a compass aboard your ship. All right, this is the bow. All right, you got north, south, east, and west. All right. Now, what happens when right now you're heading due north? Your bow is lined up with the north, right? But as you swing the ship to starboard, what's going to happen? The compass card is staying fixed while your ship is rotating around it. All right. So that compass card remains fixed. But to you, the observer, your feet are planted on that ship. Your whole body's turning with the ship. So in a relative sense, it appears as if the compass card is going in the opposite direction of your heading. All right? In this case, it's going counterclockwise. Now, when the again, if you go the other way, all right, it's going to go clockwise. Now, what you have to remember here is if variation or deviation, you apply the correction the same to both, is easterly, all right, the compass card is rotated in a clockwise direction. All right, it's going to rotate towards that easter. All right, and think of the arrow. All right. It's going to rotate in a clockwise direction. What's going to happen to these numbers? All right, let's bring this out a little larger. All right, this is north, south, east, and west. All right, up here, you're going to have, all right, this can be written as 0 or heading of 360. Now, as you move as the car moves clockwise in an easterly direction, all right, what is happening to the numbers? The numbers written right up here are decreasing. It's going to be 360, and then 359, then 358 as this car rotates clockwise. All right, the numbers are getting smaller. As the card rotates counterclockwise, as you go towards the west, the numbers are going to get larger, 0, 1, 2. All right, so let's bring this back to our equation here. Can dead men vote twice? So in this example, we're going to take a true heading of 0, 9, 0. Okay? And let's say we look at the chart. For our current location, the variation is 6 degrees east. Right? Now, we are moving in this direction, so we subtract east, all right, and we're going to get a magnetic of 0.84. All right, we subtracted. The numbers you're getting smaller. Deviation, all right. Now we look at our magnetic compass table for the heading of 0.80, and what we find out is we have a 2 degrees west deviation. All right, we are heading in this direction now, so we add west. True virgins, baked duck, companions at weddings, add west, and we're going to end up with 0.86 degrees. All right, so when your compass is reading 0.86 degrees magnetic, your true heading is going to be 0.90 degrees true. Next, we're going to take a look at adding a gyro compass to the equation and seeing how that changes things. Talk to you at the next lesson.